everyone. Mike Levin on Tuesday, February 22nd, 2022. So I guess that's 2/22/22. That's a pretty special date. I didn't even think of that at first. Well, there I time-stamped this one, but it's another one of these dark ones while I'm driving. The drive is over halfway done already, so, you know, this will be a short one. What does that mean? An hour? I don't know. Yeah, depends on what I end up talking about. What am I going to talk about? Let's see. We'll spin the wheel. And it lands on why Python is misnamed. It's certainly serving it well enough, because popularity of Python in the face of JavaScript, that speaks volumes for how good of a programming language Python actually must be in the face of the latest fad that has the magical property of being the one language to rule them all, because it's the only true language of the web browser. Lots of people are going to learn it. Once you're learning it for user interface work on browsers and mobile phones, you might as well use the same things you learned on a server environment. Oh, and JavaScript's great for it because it has non-blocking I/O. So, full web stack. And very much the siren song. Very much the, why would you not take this gift? Become a Node.js, you know, full web stack, native React or Vue.js person, because there's only a few billion platforms that can run your code, and the servers will run in much the same way as the browsers. So you have this really symmetrical application of knowledge on the different sides of a system. So it's a strong argument. I'm talking myself into it. Forget it. This is why you should use JavaScript. Not really. The fact is, every time I end up using JavaScript, which is actually quite a lot, I thank my lucky stars that Python is rising in popularity continuously, linearly for the past 30 years. It has not been fatty surges like the Ruby and the Rails, and like, I don't know, what has been more of a fad? I guess active server page, right? It was a phase of web development. I'm sure another one where Microsoft just basically stole things from someone else. I think there's active, someone who has these active technologies, and it was based on the fact that when a request was made of a web server, instead of the web server having to spin up an entirely new instance of Perl or whatever other CGI, Common Gateway Interface language, was being used to serve web requests. It's very inefficient. It loads it in memory, it loads the program into the interpreter, it executes the program, and then it dumps the entire program and interpreter from memory until the next web request comes in. Enter active, where things become persistent in memory. It's like it's in compiled, optimized form and in the computer's RAM, so the next request that comes in gets served out of that location instead of the whole chain of events and cause-effect of CGI. And I guess Microsoft said, that's a good idea, so enter active server page, where their two preferred languages was Visual Basic Scripting Edition. They took Visual Basic, a big popular Microsoft language, one of their original products, and they said it's Visual Basic Scripting Edition. It's the edition of Visual Basic for scripting. And that's what .asp pages are. Active server page are generally 9 times out of 10 Visual Basic Scripting Edition, or VB Script. VB Script is what they call it a lot. And a tiny portion was also JavaScript, because JavaScript was popular on the server back in those days, before Node.js. Netscape Commerce Server, the commercial products on the web server side from the company who brought the first popular web browser, Netscape Navigator. Well, there was Netscape Commerce Server, and that let you make web stores and stuff, and the language you would code it in was JavaScript back in 1997, 98. And so this is ancient history. And long before the browser wars and Node.js, the Node.js extraction of the Google JavaScript engine, V8 JavaScript engine, both built into Chrome. And that's where Node.js came from, and that's what created the great unification of web and server technologies. But the language is terrible. Oh my God, every time I look at what, anonymous functions are with these combinations of, arrow functions and curly brackets and parentheses all arranged in this magical order, that it becomes an anonymous function. Now, Python's anonymous functions with lambda one-liners aren't much better, so every language has its weaknesses. However, JavaScript has lots of those weaknesses, and Python has relatively few. And you have to resort to Googling up your solutions less in Python, or at least I find that to be the case. Most of the things I want to do in Python, I just write. And getting to the misnomer portion of it, why is Python misnamed? Well, because it invokes the image of this snake, of this powerful, linear hunter type, thing. And Python, it's even the logo. And Python was actually named after Monty Python, the British comedy troupe, who are cross-dressing subversives. And, the language is lighthearted and breezy, much like the Monty Python skits are. And Guido van Rossum, the creator of the Python language, said he thought the original logo for the language ought to be like the 10-ton weight that gets dropped on people in the Monty Python flying circus skits. And, no one would have got it. It was too, obtuse. People need a direct, obvious, hit them in the nose associations for memorability, for memorableness. And so Python becomes the snake. And the whole vibe of the language is misrepresented. When I help teach people Python, I'm like, okay, there's really three things you've got to learn first. One is a list, another is a tuple, and the third is a dict, or a dictionary. You learn these three things, and you learn what they're about and what they're useful for and how to interact with them, and you've learned most of Python. It's a way of thinking with a different philosophical lean behind each of these data structures. A list is this dynamic, resizable object that looks kind of like a numeric array, but whereas with numeric arrays like those found in NumPy and the Fortran programming language, there's a lot of predefined numeric sizes, so there's a certain predictability and deterministic systems in highly optimized, fast number crunching systems, right? So there's a real split here in computer science, information technology, what have you, between the deterministic, optimized, static compiled, static variable, declared static variable typed people, and dynamically data typed, inferred data types, duck data typing, container objects that can contain different types of data types. They don't have to be the same data type. So you take a list. First, you don't have to say how long that list is going to be. You add an item to the list. The first item is an integer, let's say 1. The next item, a file that is 99.9% the size of your free available space on your hard drive. It's item 2 in the list. Problem? No. It's a reference to that file on your hard drive as the second item in the list in Python. You can pop them off the list. Pop off the first item of the list, you got the numeral 1. Pop off the second item of the list, you've got this file nearly the size of your hard drive. And that is not a problem. And so one would ask themselves, doesn't it take more kind of computing resources to handle something that could have such variety in its input values? Yes, the answer is yes. It takes Python a lot of time to do the extra overhead demanded of it because lists are quite as dynamic as they are. Add things to a list, remove things from a list, take slices of a list, do, transformations to each member of a list. Lists are really powerful and dynamic, flexible objects. I would describe them as like a box that's expandable with sides that can stretch. You can easily picture a mechanism like a T-square where it can make a box larger and smaller, except that wouldn't be doing reference to it. I mean, that wouldn't be doing justice to it, because what that list can contain is a reference to something that's physically located entirely somewhere else. Reference to a herd of elephants in your Python list. So, yeah, there's a real philosophical lean to it, which makes it useful for a lot of things. You take a huge performance hit on it, but you can start wiring stuff up together quickly where, you use these features. Now, the tuple is about as opposite of the list as it can be, except it looks like a list at first because it's a series of numbers or items or objects or whatever. It can be a variety of things, but they have to be immutable. A list is mutable. You can change it. When something is mutable, you can reach into it, you can transform the shape of it, and every reference to that item gets the new shape. Oh, you've added something to the list. So you can't have a list as a member of a tuple, but you can, and in fact you want to have tuples as members of a list. So a list with a series of fixed length tuples, because that's one of the things about tuples. Once you say how many items are in that tuple, that really doesn't change. What those items are might change, but say you've got a 5-member tuple, say you've got another 5-member tuple, and say you've got a third 5-member tuple. Put those 3 5-member tuples into a list, and you've got a list of tuples that is approximately the same as rows in a spreadsheet, or rows in a SQL table, or what have you, rows in a CSV file. It's all the same, and it's all generally list management. So one of the most popular data structures in Python, because it so easily controls things and transforms into other things like spreadsheets, is a list full of tuples. Now, why not a list full of lists? Because why have all that overhead, all that extra memory, all that build up and tear down of all these dynamic objects inside a dynamic object, when all you need is that outer object to be dynamic so it can take new rows. You want the ability to add new rows, add new row, add new row, add new row. But the structure of each row is going to be the same. It's going to have the same number of columns. That makes a tuple the perfect choice for a data structure in Python to represent a row of data in a table. And lo and behold, with one simple call, you can transform a list of tuples into a pandas data frame, which is a lot more like a SQL table or an Excel spreadsheet than you might think, because of all the wonderful things built into it to do all the math operations that business people and scientists and financial people have to do to such rows and columns of numbers in their data sciences. And if it transforms from data science, or it shifts from data science, where there's a lot of strings involved, a lot of words and a lot of word parsing, if there's no columns containing words, but all your columns instead contain numbers, and particularly numbers of fixed sizes, well, then you dump pandas data frames in favor of NumPy numeric arrays, which are rocket science, which loosely, are loosely the same as Fortran, which is, it's modern Python's answer to the Fortran programming language, which exists to calculate parabolic projections during war, right? ICBMs and all that type of stuff. That's why Fortran exists, a very IBM-like technology whose original versions was written very much for the hardware it was running on. So when people say, what was life like before Unix and Linux, when all software was portable between operating systems, the answer was like, well, it was a lot like Fortran, because Fortran came from IBM and only ran on IBM hardware. So IBM sold you the hardware to run the application, to run, your calculations, to, calculate missile trajectories. And nobody really cared about all the difficulty because, it was heady times and money was no expense and America was an economic powerhouse. So mainframes. And then things get smaller, the machines get smaller, and the needs for computers get broader. And languages like Fortran become more niche. They become obvious as niche languages, more so for what they are. And then a variety of languages blossom along those times. And a methodology for porting software between operating systems and porting operating systems between hardware all develops. And that's a magic 1-2 punch combo. It's the C programming language and its corresponding C compiler, mostly known as GCC these days. It comes from an organization that decided to get all the benefits of Unix without being Unix. And it was called GNU. And GNU stands for GNU is not Unix. All right, so the self-referentiality geek humor, Richard Matthew Stallman, RMS, the rise of the free software movement, the transformation of that into the free and open software movement, and then the rapid materialization of different licenses with different willingness to give away for free with varying conditions that free and open source software. And then add, feedback loops of systems like GitHub, which is built on software like Git, which comes from Linux, which comes from another attempt to reverse engineer Unix without being Unix. Now, an interesting part that, more and more people know, but it's still a little known fact, is what we talk about as Linux today are pieces contributed mainly from two people. Linus Torvalds has contributed the really low-level hardware driver pieces. Linux was for 386's first. It has subsequently expanded, but Linux is the low-level intimate knowledge of hardware that breathes that first Frankenstein moment of it's alive without being able to do very much else. You're lucky if you have a type-in terminal at that point. But then control is handed off to the other side of the equation, which is a bunch of little commands, programs for that low-level minimal operating system. Enter the Unix/Linux commands, which are the GNU command set. It's your ls for listing the contents of directories, your cd for changing directories, and little programs like that, which collectively give you everything you need to get software running, to move files around, to write scripts that can auto start your software when the machine powers on. So the low-level stuff hands control over to higher-level stuff, usually with text files. All tech is text files at some point. If it's not, then it's text files that have been compiled into other forms, binary large objects. Or, things that were captured with sensors, like photographic images, which when you break them down far enough can be represented as text files. Truly, it's binary, but binary is a low-level implementation you don't need to deal with, because the part of the API that humans are exposed to, the part that we interact with, is text files. It's a rare person who actually twiddles the bits that are sitting on, usually magnetic media, the on-offs of the hard drive. No one programs anymore by throwing switches. It's possible. It's possible. And it's something that should be done in very, very low-level operations. Building your first half an addition operation is pretty doable by, pick your poison. Legos, rubber bands and pegs, waters and tubes, anything with moving parts that are moving between different kinetic potential. Water running downhill, ball bearings running down an incline. All that has computing power because those things moving from a higher potential to low hit a switch, and the small details about whether that switch sends something left or right is your 1 or 0, your on or your off, and everything is really built up from that. But thankfully, humans don't have to think about those low-level implementations because, layers, lots and lots and lots of layers. And each layer takes care of some complexity, some operations, some transformation of what you're really operating on in a way that makes it most understandable, least complex. And so all of tech is text files, and those text files are pushed around to varying levels of complexity in a greater system. And we, as whatever operators, if we're users, come in at the most designed for human level of like working a mobile app, touching a touchscreen, and developers come in at a slightly lower level of like editing text in a text file or a development environment. And still lower level people will deal with driver development. A new piece of hardware is created, and that piece of hardware needs to be talked to by some other piece of hardware that controls it. Somewhere in there is low-level communication. There's a stream of bits that just won't make sense to a human because it's just dropping values into locations in memory that has meaning to the device, but not much to the human. Take enough of those, dropping memory things into certain locations, give it a label saying, oh, that's addition. Give that label a word like sum, give it a parentheses, create rules for orders of operations, and finally you have something that a human can interact with, the sum function that you can use in a cell of Excel, or you can use in the Python programming language and most other languages. And you'd think, oh, well, that's all just obvious. That is, so many languages share that same premise and that same syntax. Well, no, as I was giving the overview of flavors of technology out there, and I think I've given a pretty good flavor of Fortran as the rocket science language made mostly by IBM in the early days, mostly for running on mainframes, mostly for calculating parabolic trajectories, which is still around today. You can't, Fortran will never die because it's good at what it was designed for, and it's continuing to do it well. COBOL, on the other hand, while still around, it was for the state of business, in the 1960s and 70s when it was developed and used so much. It was so much geared for this how business worked that it's not really the general business language of choice when new systems are being built anymore. Not that Fortran is for rocket science much anymore either. However, it could be, I think, more truly than COBOL could be. I'm sure there's some COBOL advocates and aficionados out there that could set me straight on that. But it was a high-level language created by a woman, Alice Cooper or something? I forget her name. I always forget her name. I get it mixed up with that rock and roll person. But one of the first high-level languages written for computers, for business people, whereas Fortran was written still fairly low level for scientists, number crunching. COBOL was written high level for business people, balancing spreadsheets. Anyway, so personalities of languages. That's another case of it being specific to a problem domain. Business, COBOL business, Fortran rocket science. Well, what about in the modern age? Yeah, well, this all started out as a discussion of why Python is misnamed. It should just be called like thinking. It should be the English of, machine operation control in our minds. You can think in Python very easily. Once you have the general, ways that lists, tuples, and dicts work, you can manipulate them around in your head, and you can actually do some coding in your head fairly easily. Use Jupyter Notebook or Jupyter Labs enough. Jupyter Labs, I get plural and singular mixed up on those all the time. But use an exploratory code environment with a language like Python for long enough, and it starts to get into your head, and you start to have a little simulator of Python in your head. And you refer to Google less, Stack Overflow and Stack Exchange or whatever those sites are. You start to refer to them less, and you start to think in Python and use its little tricks and nuances, list comprehensions, more and more just naturally, like as if it were a spoken language. So that almost, so what I was saying with my friends is that, I'm slow on the uptake. I'm a perpetual noob. I was a slow reader, but I would always read these thick, fantasy novels, in middle school and high school, and they're like, what are you doing in this slow readers class? And I'm like, I don't know, what am I doing in this slow readers class? It does take me a while to get through Lord of the Rings and Lord Fal's Bane, but I'll get through them. And I've always had problems with other languages, Spanish, French, and all the languages you have to take in high school. And a brief attempt at learning Japanese when, it looked like, that was going to be